Today we're doing Calculus, Chapter 3, Section 2, the product and the quotient rules. I'm your host, Dr. D. Okay, let's get started here. Alright, so we have a function, f of x equals x times e to the x. Now we'd like to know what f prime of x is. In other words, we want the derivative of x e to the x. So, let's check that out. Seems to me the derivative of x is 1. And, oh no, it's in blue, how embarrassing. And the derivative of e to the x, we all know, is e to the x. So that should be it, right?
Nice try, but I'm afraid you can't do that.
What?
Inconceivable!
It's not the way to do it. We need the product rule. The product rule! That was backwards. The product rule! Okay. The product rule says that if I want the derivative of a product of two functions, then what I need to do is I need to take the first function times the derivative of the second, plus the second function times the derivative of the first. Now, the proof for that is in the book, and you should check it out. But basically right now, we're just going to commit this to memory, and in a very short time, it will be really easy for you.
He's laying back in the cot, peeping at this here homie. Yo, Pops, me some cheddar. Some player haters be throwing salt in my game, grilling me over my gear. Not needs to be Mackin style.
Okay, so the derivative of a product of two functions, first times derivative of the second plus second times derivative of the first. That's it, piece of cake. All right, so while we're at it, let's check out the quotient rule, and then we'll do a bunch of examples with products and quotients. So the derivative of the quotient of two functions is going to be the derivative, is going to be the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. Now, this gets a little bit tricky to remember what comes first and derivative of what and what function. So there's a simple rule to remember that. It's low D high. The bottom times derivative of the top, low D high, minus high D low. Square the bottom, and away we go. Let's do that again. Low D high minus high D low. Square the bottom, and away we go. Now, there's music that goes along with that, but I can't record the music on this video for copyright purposes, of course. So you'll have to ask me about that in class tomorrow. Okay, so low D high minus high D low. Square the bottom, away we go. Now, Notice if you mess up the order, and let's say we go high, D low, minus low, D high, square the bottom, and away we guy, so it doesn't rhyme. So obviously, in order to make it rhyme, you have to have low. So we have square the bottom, and away we go. All right. So clearly we all have that now. Let's try some examples. All right, so this time, we're not going to fall into that trap. We know that to get the derivative of the product of these two functions, we have to go first times the derivative of the second. So the derivative of e to the x is e to the x, plus second times the derivative of the first. All right, now, if I want to put that together, notice both terms have an e to the x in them, so it just becomes e to the x times the quantity x plus 1. Bam. That's it. Piece of cake. All right. Now, let's try another one. F of x equals the square root of x times 1 minus x. So, we could go, this really equals x to the 1/2 times 1 minus x. All right, so if I go first times the derivative of the second, so it's first times the derivative of the second is the derivative of 1 minus x. Well, derivative of 1 is 0, and derivative of minus x is negative 1. So this becomes x to the 1/2 times negative 1. So first times derivative of the second, plus second times derivative of the first. Now the derivative of of x to the 1/2 is going to be 1/2 x to the negative 1/2. All right, so let's simplify this. X to the 1/2 times negative 1 is negative square root of x. And then plus 1 minus x times 1/2 x to the negative 1/2 means we've got plus 1 minus x over 2 square root of x. This is times 1/2 and times x to the negative 1/2, which puts square root of x on the bottom. Now, I could doctor that up and get it in simpler form, but this is basically the calculus. First times derivative of the second, plus second times derivative of the first. Now, one thing I want you to be careful of, though, is don't just jump right into the product rule when you don't have to. This is an example of a problem like what we had from section 1. If I just distribute my x to the 1/2, then what I have is f of x equals x to the 1/2 times 1 minus x to the 1/2 times x, which is 1/2 plus 1 is 3/2. Notice I'm multiplying the square root of x times x, and that's going to be x to the 3/2. Now, if I want to do the derivative of this, all I do is the derivative of the first one is 1/2 x to the minus 1/2, and the derivative of the second one is 3/2 x to the minus, to the 1/2. Okay, notice I bring this down and then drop it by 1, so dropping 3/2 by 1 makes 1/2. And so I could simplify this as 1 over 2 square root of x minus 3 square root of x all over 2. Now, believe it or not, if we algebraically manipulate either of these, it comes out the same. But the moral of the story is, sometimes the product rule isn't the easiest way to go. Sometimes it's easier to just distribute and end up with a simple two terms that take the derivative of each one. You don't need the product rule. Okay, cruising onward. Now, in this case, we're given that f of x equals the square root of x times g of x. Then we're given that g of 4 is 2, and g prime of 4 is 3. And we're looking for f prime of 4. Okay, now this is one of those examples where you might not be sure what to do. So let's basically do what we know to do. If I'm looking for f prime of 4, then let's get f prime of x. Okay, so f prime of x here equals the first times derivative of the second plus the second times derivative of the first. Now the derivative of x to the 1/2 is 1/2 x to the negative 1/2. Okay, so yeah, let's just leave it like that. Now what we're doing is we're looking for f prime of 4. So all I do is I put a 4 in everything. So put a 4 in for x everywhere. So the square root of 4 is 2. And g prime of 4 is 3. And g of 4 is 2. And 1/2 times 4 to the negative 1/2. Now, 1/2 times 4 to the negative 1/2 is 1/2 times 1 over the square root of 4, which equals 1/2 times 1/2, which equals 1/4. Okay, so that's what this term equals, is 1/4. All right, so now what we have is 6 plus 1/2 equals 13 halves. That's it. Let's see, did we do that right? Yeah, that's actually right according to the book. Okay. All right, let's cruise onward. We're good with the product rule. Basically, you just need to keep in mind first times derivative of the second plus second times derivative of the first. Keep track of everything. Now, here's one where we need the quotient rule. So y equals this, we want y prime. In other words, we want the derivative of this. So that means we go low d high. So low d high. So I want the derivative of the top, which is 2x plus 1. There's low d high minus high d low, which is 3x squared. Square the bottom, and away we go. Low d high minus high d low, square the bottom, and away we go. Okay, so now we just got to clean it up. So we've got the top, I've got x cubed times 2x is 2x to the 4th. Let's see, plus x cubed plus 12x plus 6 minus, okay, 3x to the 4th minus 3x cubed plus 6x squared. All divided by. Now, you may be tempted to factor that out, or I mean to distribute that out. But really, factored form is always simpler. So you always want to leave it x plus 6 quantity cubed. There's no reason to go x to the 6 plus 12x cubed plus 36. So that would go the opposite direction we want to go. The only reason we multiplied these out on top is because now I can combine like terms and factor if possible. So I end up with y cubed equals, now we've got our x to the fourth, 2 minus 3 is a negative x to the fourth. And then we've got our x cubed, which is 1 minus 3 is minus 2x cubed. And then we've got our x squares, which is a plus 6x squared. And then we've got our x's, which we've got a plus 12x. And then we've got our x to the 0, which is plus 6. All over x cubed plus 6 quantity squared. Now, it's possible we could factor this top, but that's totally unnecessary at this point. We did that back in Algebra 2, so we don't need to do it anymore. Okay, so let's see how the book ended up with that one. Yeah, okay, they quit the same place we did. All right, that's it, game over. All right, now, one thing I want to show you is sometimes you're going to be given a problem that's going to be tempting to go with the quotient rule, just like I showed you with the product rule, but it's not necessary. Let me show you an example of that. If we have y equals x cubed minus 3x squared plus 2x minus 5, all divided by x squared. And we want y prime. Now, you might be tempted to go low, d high, minus high, d low, square the bottom, and away we go. But then you'd end up in a giant mess.
I think I shall now be thick.
Okay, so you don't want to do that. You want to simply simplify your original function. Notice if I simplify this, x cubed over x squared is just plain x, minus 3x squared over x squared is just minus 3, plus 2x over x squared, which is just plus 2 over x, minus 5 over x squared, which then equals x minus 3 plus 2x to the negative 1 minus 5x to the negative 2. So when we do our derivative, it's going to be much simpler. The derivative of x is 1. The derivative of minus 3 is 0. The derivative of 2x to the negative 1 would be minus 2x to the negative 2. And the derivative of minus 5x to the negative 2 would be plus 10x to the negative 3. And so there we are. To simplify this, we'd have y prime equals 1 minus 2 over x squared plus 10 over x cubed. And if I wanted to put it back into a single fraction, then I could say y prime equals x cubed minus 2 yeah, x cubed minus 2 plus 10, oh wait a minute, no, 2x. Getting a common denominator, basically. So the common denominator is x cubed. So it's going to be okay, there it is all in one fraction. So notice how much simpler this was to take the fraction, break it up into 4 bite-sized chunks, and then just take the derivative of each one, and then you can put it back together if you want to. But doing the quotient rule would just be way more work, and then you'd have to simplify it anyway. So that's it. Remember that lesson. Okay. Okay, now, our final example problem, we're given this function y equals e to the x over 1 plus x squared, and we want the equation of the tangent line to that curve at x equals 1. So how do we get the equation of a tangent line? Well, remember, the derivative of the function is the slope of the tangent at any given point. So what I want is the derivative of y. So let's mess around with a little bit different notation. Instead of calling it y prime, let's call it dy dx in honor of Mr. Leibniz. So, so the derivative of this thing is going to equal low d high minus high d low square the bottom. Anyway, we get. So now, remember, we want the derivative of this at x equals 1. Now let's clean this up a little bit. So we're going to say this is 1 plus x squared times e to the x minus 2x times e to the x. So I can factor an e to the x out of the whole thing. And I have x squared minus 2x plus 1 all over 1 plus x squared squared. And let's go one more step. X squared minus 2x plus 1, we can factor that into x minus 1 quantity squared. And let's make this x squared plus 1 quantity squared, just because I like having the x first, which for some reason our textbook likes it the opposite. So here we are. Now we want the slope of the tangent at x equals 1, which means we want the value of the derivative at x equals 1. So that's how you notate the derivative at x equals 1. So we're going to plug in 1 into here, and we have e to the first times 1 minus 1 squared, which is 0 on top, and 2 on the bottom. Oh, I'm sorry, 4 on the bottom. Who cares? So that means the derivative at x equals 1 turns out to be 0. Now what did that tell us? The slope of the tangent to that curve at x equals 1 is 0, which means it's a horizontal line. So if it's a horizontal line, then we need to know the y value to figure out where it is. So what's the y value at x equals 1? Well, let's put that in. So y at x equals 1 is going to equal e to the first over 1 plus 1 squared. So that's e over 2. So there's our equation of our tangent line, is y equals e over 2 bam, that's it, game over. Okay, now let's take a look at that graphically and see what actually just happened. So, all right, so we've got, nice, I didn't really want that. Oh. Oh, no, it's not coming back. That dirty rat. Okay. We don't even need it. All right, so here is our curve of e to the x, e to the x over 1 plus x squared is the blue curve. And at x equals 1, notice the tangent line there is horizontal. And what's the value of that tangent line? Well, it's going to be y equals e over 2. So that basically shows us the value of, or the equation of the tangent line at x equals 1. Now we could have the equation, the tangent line at any x value. All we have to do is go back to our original derivative. We go back to our original derivative right here and put in any x value we want. That gives us the slope. And then all we would have to do is get an x value and a y value and a slope. Once we have an x value, y value, and a slope, then we just go y minus the y value equals the slope times x minus the x value. That's it, game over. Have fun with the